Right, welcome back. We are looking at question 4.2.1, last year's Core Maths past paper 2. So they ask us to find the length of the radius of the smaller circle. Now, they've given us the equation of the smaller circle, but it's not in standard form. If we can get it into standard form, however, the radius should be very easy to calculate. So the first thing to do here is to group up your x's and y's. So we have x squared and 24x, y squared, negative 10y. And let's immediately take this constant across to the other side, because we know we're going to want it there, to find our radius squared. Now, remember, we want to get it in the form of this bracket, right? X plus something or x minus something squared. What I recommend you do here, have a look at your coefficients and add in, I'm going to represent the coefficient by letter C. Add in half of them squared. By what I mean, 12 squared minus 5 squared. Whatever you do to one side of the equals, you have to do to the other side of the equals. So 12 squared and minus 5 squared. Right, let me just write down coefficient all over 2 squared. That's what you're putting in if you have a question like this in your exam. Okay, now that we have these much easier groupings, it's just a simple trinomial here. X plus 12 squared plus y minus 5 squared. And this, you can just use a calculator, don't worry about it. Right, so if you use a calculator, you'll end up with 16, right, because this is 144. And this should be 25. And you minus that. Right, I'm not going to go through the arithmetic with you. You don't need to do it. But 16, we can already tell right away it's 4 squared. And just like that, we've got it into standard form. 16, we know it's 4 squared. The standard form ends in r squared. Therefore, the radius of the smaller circle is 4 units. Right, so at first this looks like a bit of a complicated question. The biggest thing to remember is to add in this to both sides of the equals, and then you can find your answer from there. Okay, I'm going to pause, erase the board, we'll go into 4.2.2. Right, so 4.2.2 asks us to calculate the length, let me use a different color, the length of TS, that line there. Now, we are told immediately that line NT, or rather that T lies on the circumference of circle N, and S lies on the circumference of circle M. What does that tell us? That tells us that NT is equal to the radius of N, and MS is equal to the radius of M. Right? Furthermore, we know that NTSM is one line. So, we can say that NM minus NT minus MS should equal TS. Right, that's all just logic. We haven't gotten to the maths yet. But knowing what we can do, let's start with working out distance NM. Right, how do you work out distance? Well, the distance squared is the 1x minus the other x squared plus the 1y minus the other y squared. Right? It's just difference of x and difference of y. This is Pythagorean stuff. We can immediately put the square root right there. So the x of n, well, we worked out the standard formula of n in the last question, so we know it's negative 12. The x of m, it was given to us, or slash we worked it out fairly easily. It's minus 6. The y of n, again we worked it out very recently, it's 5. And this should be minus 3 squared. Put that all under the square root. Okay. In other words, this is just arithmetic. Don't worry about it too much. Your final answer should be the square root of 100. So it should be 10. It's going to be a positive number. You don't have to worry about that plus minus because working with distance. Distance is always positive, at least in high school. Okay, good. So we have this value. Nt, we know it's the radius of n. That's something we just worked out. So we know it's 4 units. We know ms, the radius of circle M, it's 5 units, has to be the square root of this number. And that should equal to ts. What do you know? It is a single unit. Right? You can, in fact you should, have a line here just saying, nt is equal to 4 and ms is equal to square root of 25 is equal to 5. Yeah, should put in those lines, but here's how you work it out. Easiest way, find the distance between those 2 points, subtract the 2 radii, you get what's left. It's 1 unit. Okay, that is 4.2.2. I'm going to pause, erase the board, move on to 4.3. Right, so question 4.3.1 is quite a simple one. They want us to work out the equation of tangent PR. Now, at the very beginning of the question, they already told us that PR is parallel to the x-axis, which means our equation is going to look something like that, c being some number. Right, we don't need the mx, because the m is going to be 0. 0 gradient puts parallel, so this part we can just kind of rub out. It's not a big deal. So all we need to know is how far down on the y-axis is this line. And now this is where it gets interesting. Because these two are parallel, and because this is a tangent and this is a radius, what's a rule of tangents and radii? They are always at right angles, right? So PR is perpendicular to MR. That means that MR is a straight line down. So whatever the y value of M is, you just have to minus it. Sorry, it's not very bright. Let me use this. Whatever the y value of M is, just minus it by the radius of circle M, and you should get the y value of R. Okay? The y value of M, very easy to see, it's -3. The radius of M, well, it's the square root of 25. Right, just because we were given the equation of circle M. So -3 minus 5 is equal to -8, which is equal to the y value of R. Therefore, line, or rather tangent PR, y is equal to -8. Horizontal line, that's all there is to it. Cool. So, as usual, I'm going to pause, erase, I'm going to go to 4.3.2. Okay, 4.3.2 asks us to calculate the equation of line PS. That line there in the form y equals mx plus c. So for this question, no matter how you do it, you need to do a gradient calculation using 2 points. So I'm going to show you 2 different ways. Let's start with using n and m. Okay? So, the gradient of the line nm, is the change in y over the change in x. Right? So that's the one y minus the other y over 1x minus the other x. Okay? So that's 5 minus 3 over negative 12 minus 6. Our answer there should be negative 4 over 3. Right, so that's our equation the gradient of nm. And something that we always know is tangents are perpendicular to radii. And nm forms, well, the radius of m forms part of nm that we just calculated. So the gradient of ps is equal to the gradient of nm times by negative 1, and then flipped. In other words, it's 3 over 4. Cool. So we found that gradient. Now, we have a point on this line. We have k. So y equals mx plus c. We can use k's y value, negative 5. We can use the gradient that we just calculated. We can use k's x value, negative 17, to find our constant. So that means negative 5 equals negative 51 over 4 plus c. And this is just a bit of algebra flipping. I'll spare you the details, but c is equal to 31 over 4. Great, that means okay, hope you can see that. We have our equation. Y equals 3 over 4x plus 31 over 4. So that's the first method. I'm going to pause, quickly erase, and show you the other method. Cool. So if you want to keep down this method, take a screenshot quickly. Okay. Okay, so this other method requires finding the coordinates of S. Now this actually isn't all that difficult because we know ms is the square root of 25 is equal to 5, right, because it's a radius of circle M. And nt is equal to square root of 16 is equal to 4 for similar reasons. And we know that ts is equal to 1. Calculated that in a previous question. Therefore, ns is equal to 5, ms is equal to 5, therefore s is a midpoint nm. And if something's the midpoint, it's very easy to calculate its exact coordinates. What you do is you average the x's and you average the y's. So that's negative 12 minus 6 over 2, and 5 minus 3 over 2, which should get us -9, 1. Great. We found the coordinates of S. With, right, let me just write here, erase most of this quickly. The reason why this is so useful is now we have 2 points on a line. So let's have K, right? It's -17, -5. If you have 2 points on a line, you can calculate, well, the entire line. So what's the gradient of the line? Like in the previous method, it's the change in y over the change in x, which is y of s minus y of k over x of s minus x of k. In other words, 1 minus -5 over -9 minus -17. That's a total of, that should be 6 at top, and how much is that? 8 on the bottom. So that's 3 over 4. The same gradient we found with the other method, right? It should be. If it wasn't, I would be doing something wrong. It's not unheard of. Anyway. Great, so we found the gradient. So let's plug this into our standard form for a straight line graph. Let's use S, right? 1 is equal to 3 over 4 times -9 plus C. Sorry, here. 3 times 9 is 27, so that's, what, -27 over 4 plus C. Take the 1 across, or I'll take this across. 1 plus 27 over 4 is equal to C. That 1 is just equal to another 4, basically. So that makes 31 over 4 is equal to C. Again, the same C value as we had before, so we can say y is equal to 3/4 of x plus 31 over 4. Okay, that's 2 different methods for doing the same question. Use either. If you happen to forget about the perpendicular rule, then this method's a bit easier. If you didn't catch that S is the midpoint between N and M, then the previous method's a bit easier. I would say either are totally acceptable. Alright, same as usual. I'm going to pause, erase, and we're going to move on to question 4.4. Right, so in question 4.4, we are told that quadrilateral PSMR is drawn. Alright? Don't worry about this triangle, it'll come in very soon. PSMR, those are points of the quadrilateral. And they want us, I've been using purple, to find the perimeter of that quad. Now, probably the easiest way to do this just break it up into its component parts, right? It's PS, SM, MR, and PR. A couple of these we already know, right? MS, we already know is a square root of 25 is equal to 5. Why? Because it's a radius. We've looked at that particular equation like 4 times. Cool, we know that one. Same thing with MR. Square root of 25 is equal to 5. If you want a reason, you can just say radius. Okay, so the things that might give us a bit more difficulty are PS and PR. However, once we find the coordinates of P, we should be fine. And how do we find the coordinates of P? Well, okay, I reckon the easiest way is first find coordinates of R. Now, we already know that R is on this line here. It's -8. And it's also directly down from M. So it shares an x value with M. So it should just be -6, -8. Yeah, there are lots of ways to calculate that. You can calculate using this line, which is basically what we just did. You could first find P and then find R, but yeah, anyway. Now we know that the length of PS should be the length of PR. Why is that? They are tangents from the same point, tangents of the same circle originating from the same spot. So they are of equal length. So we just need to find the length of one of them. Either will do. Let's find the location of P quickly. So P lies on this line that we've worked out right here, right? And we know its y value because it shares a y value with R. So, okay, sorry. Y equals 3 over 4, x plus 31 over 4. We know that y is -8. Cool. Now, let's times everything by 4. That's probably the easiest way to do it. -32 is equal to 3x plus 31. Let's carry that 31 across, so it becomes -63 is equal to 3x. Divide both sides by 3, that's -21 is equal to x. Therefore, P is in location, or has coordinates, -21, -8. Cool. Now that's where I'm going to write this here. It's very useful because now we have all the information we need to find either PR or PS, but they equal the same thing, so it's really not a huge deal. I'm going to go for PR. Yeah. So, PR. As with all distances, it's just a Pythagoras thing, right? It's the x of P minus the x of R squared, the y of P minus the y of R squared. These two things can be swapped, it doesn't matter. So this lands up basically 8 minus 8. So that part's not going to matter much. And -21 plus 6. Our final answer should give us just 15. Remember, you don't have to work this out in your head, you don't even have to work it out on paper, just put it in your calculator, saves you time, saves you effort. Okay, so we know the distance of PR is 15. We could have worked it out much more easily, even. We know that the same y coordinates, the x coordinates are different by 15. Right, I'm going through all the motions so you can see how to do this. Great, so we have these values. And those are the only two extra ones we needed. So PS MR is equal to the two 5s. Let me write a bit neater here. 5 plus 5 plus 15 plus 15 for a total of 40 units. That's the length of the perimeter PSMR. Okay, so a bit of a long one, but it was 5 marks. I'm going to quickly erase and show you the final 2-mark question within question 4. Now the beauty of question 4.4.2, which asks us to find the ratio between this triangle, NSP, and the quad we've just been looking at, PSMR. NSP over... The beauty of it is, because of all the maths we've done to get to this question, this becomes immensely easy. So easy, in fact, that we don't even need to use units. Okay, we just have to remember how to do equations of area. So the area of a triangle, it's a half breadth times height. And a quad like this, certainly the easiest way to do this is to divide it into 2 triangles. They're both right angled. We found those right angles long ago. So this becomes very, very easy. Okay, admittedly, if I keep using breadth and height, it's going to be a bit tricky. So let's say breadth and height 1. And if you're clever, you've probably already seen exactly where this is going. But breadth 1 of this triangle doesn't really matter. Let's call the breadth NS. And height 1 we're going to call PS. Breadth 2, let's call it this triangle here, let's call the breadth MS. And PS will be our height again. This breadth, let's make it MR. And the third height, let's make it PR. Okay. In previous questions, we've already seen that S is the midpoint of NM, right? Therefore, NS is equal to MS. We also know, because these 2 lines, PS and PR, are tangents coming from the same point, that they are also of equal length. Right, so we can call this proved above. And this is tans from the same point. So this equation here becomes a half NS PS over half. We can substitute with NS, it's fine. And PS plus a half NS PS. What a coincidence that it's working out so easily. Now, you can probably just see right off the bat that that is just equivalent to 1 over 2, right? You can switch these out for A over A plus A if you wanted. You know, there's so many ways you can prove it. Please do not go through the trouble of inputting all the values. I mean, you could, it's only 5s and 15s, but really you can see right off the bat, it's just 1 over 2. That's, I believe, definitely the easiest way to do it. You could also go for a coefficient triangles route. I feel like that's going to take you a little bit longer. Okay, and that's the end of question 4 for last year's June Mathematics Paper 2 exam. Right, that's all from me. Good luck.